Today we're going to be talking about greatest common factors. Factors are not a new term to you guys in math. In fact, we've talked about them before. So, for example, if I ask for factors of 6, what are the things that you could give me? What are the factors of 6? Well, if you need a refresher, factors are just numbers that we multiply together to get, for example, 6. So factors are what you multiply together to get that number. So we can multiply 1 and 6 to get 6. Well, 1 and 6 are factors. We can also multiply together 2 and 3 to get 6. So there are only 4 factors, and those factors of 6 are 1, 2, 3, and 6. Now, today we're talking about greatest common factors, and you'll generally hear those called GCF for short. So your GCF, or your greatest common factor, what do you think that might be? What would that look like, or how could we define that? So greatest common factor is exactly what it says. It's just your factor that's the largest between two given numbers. So you might see something written as GCF and then in parentheses 2 numbers. So for example, 12 and 15. Now you could sit back and start saying to yourself, all right, I'll start with 12. What can I multiply to get together to get 12? 1 and 12, 2 and 6, 3 and 4. And then I'm going to do the same thing with 15. 1 and 15, 2 doesn't work, 3 works, 3 and 5, 4 doesn't work. So these are the only factors. Then what I would look for is factors they have in common. They have 1 and they have 3. Which one's bigger, 1 or 3? Obviously 3. So the GCF of 12 and 15 is 3. That's fine and dandy. But the problem starts coming in when you find yourself with this question. What's the GCF of 100 and 225? Now you have to sit back and think, do I really want to sit here and list out the factors by hand? 100 and 225 are pretty big numbers, so that might take a lot of space and a lot of time. So there's actually a different way that we can look at this, and it's called the grid method. So basically what you do here is you make a lovely little grid. Whatever your two numbers are, so 100, in our case it's 100 and 225, you're going to put them shifted over towards the right. So you want that left column opened. And what you're going to start doing is you're going to ask yourself, what factors could I factor out of each of those? Or a better way of thinking of it is, what could I divide out of both 100 and 225? So for example, I know since 100 ends with a 0 and 225 ends with a 5, I can divide both of these numbers by 5. So whatever I can divide by, I'm going to put in my left column box. And then this here, the next line down, is going to be the answers when I take, for example, 100 divided by 5. 100 divided by 5 is 20, so 20 is going to go in this box. And then I'm going to do 225 divided by 5, which is 45. I literally am just going to do that same process until I can't do it anymore. So I'm going to look at the next row. I don't have to look at this top part anymore. I'm done with it. I'm going to just focus on the second row. So when I'm looking at 20 and 45, what can I divide out evenly? Well, again, they end with 0 and 5, so I can divide out of 5. When I divide 20 by 5, I get 4. When I divide 45 by 5, I get 9. Again, just move down to the row with the numbers. Now I ask myself, what can I divide evenly out of 4 and 9? Unfortunately, I can't divide anything. So when that occurs, the only thing you can divide out is 1, and we call that one and done. So that means I don't go any further. So now to find my GCF, all I have to do is look at the leftmost column. And I'm going to circle that column. The numbers that are in that column that I've circled, I'm going to take them. So I have 5, 5, and 1. I'm going to multiply those together. So 5 times 5 is 25, and 25 times 1 is 25. And guess what? That's my GCF.